For years, we were told Jupiter was a giant ball of gas with a few storms on top. But that picture is starting to fall apart. Because the deeper scientists looked into Jupiter, the stranger it became. And when Juno sent back new data, it revealed something nobody expected. We may have misunderstood the largest planet in the solar system this entire time. So what is Jupiter really hiding beneath those clouds? Before diving into the mysteries hidden deep within Jupiter, we need to step back and understand the broader picture of this enormous structure and how it shaped the fate of the entire solar system. When we look beyond Mars into the outer regions of the solar system, we find a giant that overshadows everything: Jupiter. Humanity has been observing it for nearly 400 years, and for a long time, we believed it was nothing more than a massive ball of gas. That's how it was taught in schools and how it was written in textbooks. But today, thanks to NASA's Juno mission, we know that Jupiter is not an empty sphere made only of clouds. It is a cosmic powerhouse that sets the rules of the solar system, so massive that it even makes the sun itself subtly move. It is incredibly difficult to truly grasp Jupiter's size. If it were hollow, it could fit about 1,000 Earths inside it. But what is truly astonishing is its mass. Jupiter is more than 2.5 times as massive as all the other planets, moons, and asteroids in the solar system combined. This overwhelming dominance makes it the most important player in the system after the Sun. So how did such an enormous mass come together? Jupiter formed around 4.5 billion years ago, when the solar system was still chaotic and filled with drifting material. Far beyond the Sun, in a freezing region where ice could survive, Jupiter began building itself from enormous amounts of rock and frozen matter. Its core quickly became massive, far larger than Earth. And once it reached a critical size, everything changed. Jupiter started pulling in hydrogen and helium at extreme speed, swallowing huge amounts of material left over from the birth of the Sun itself. That runaway growth is what transformed Jupiter into the giant planet we see today. Most people imagine planets simply circling the Sun in clean, perfect paths, but Jupiter doesn't quite fit that picture. In reality, the Sun and Jupiter don't behave like a one-way system. They both orbit a shared point in space called the barycenter. For Earth, this point is buried deep inside the Sun, so nothing seems unusual. But Jupiter is different. It's so massive that this balance point actually sits outside the Sun itself, meaning the Sun doesn't stay perfectly still. It subtly wobbles as Jupiter pulls it around. Jupiter's immense gravity also makes it a kind of guardian for Earth. Astronomers often refer to it as the vacuum cleaner of the solar system. It captures or deflects dangerous comets and asteroids, either pulling them into itself or slingshotting them out of the system entirely. Without Jupiter, Earth would likely have faced far more frequent and catastrophic impacts. When you look at Jupiter, you are not really seeing a planet. You are witnessing a constantly shifting, living landscape. At first glance, the massive bands wrapping around its surface appear calm and orderly. But this is an illusion. Each of these bands is formed by powerful atmospheric currents, winds moving in opposite directions at incredible speeds. The lighter regions represent gases rising upward, while the darker bands mark areas where material sinks back down. As these systems circle the planet, they collide, shear past one another, and continuously create new structures. That's why Jupiter's surface is never truly still. It is constantly changing, always in motion. And this motion is not limited to what we see at the top. It extends deep into the planet. Clouds rise, expand, cool, and collapse again. This cycle operates like a massive engine, constantly fueling the atmosphere. Within this system, enormous vortices occasionally emerge. The most famous of these is the Great Red Spot. This gigantic storm has been observed for centuries. It is so large that multiple Earths could fit inside it. But what truly makes it remarkable is not just its size, it is its persistence. While even the most powerful hurricanes on Earth disappear within weeks, this storm has endured for hundreds of years. Jupiter's atmosphere doesn't stop there. Across the planet, hundreds of storms of different sizes rage at the same time. Near the poles, massive cyclones form almost perfect geometric patterns. These storms balance each other, push against one another, and maintain their positions for long periods. Nothing like this exists in Earth's atmosphere. Another striking feature is the color. Jupiter's iconic yellows, oranges, and browns are not random. They are the result of materials rising from deep within the planet and interacting with sunlight. Every color you see is a reflection of processes happening far below. But there is a critical truth here. All of this grandeur is not the whole planet. These enormous clouds form only the outermost layer of Jupiter. They are dazzling, dynamic, and mesmerizing, but also deceptive, because beneath those clouds an entirely different world is hidden. To understand what lies beneath Jupiter's thick and toxic clouds, humanity needed one of the most resilient machines ever built. That machine was Juno. Launched in 2011 and arriving at Jupiter in 2016 after a 5-year journey, this spacecraft was unlike any probe before it. So how did Juno detect what lies beneath a layer of clouds? The answer lies in a simple law of physics: gravity. If Jupiter were a perfectly uniform ball of gas, Juno would follow a smooth, uninterrupted path as it orbited the planet. But every time Juno approached the cloud tops, Jupiter's gravity would subtly speed it up or slow it down. Scientists on Earth measured these tiny velocity changes using the Doppler effect. When all this data was combined, it revealed a detailed map of how mass is distributed inside Jupiter. And in that moment, the century-old gas giant model began to collapse. Juno's gravity maps showed something astonishing. Deep within Jupiter, under immense pressure, hydrogen was no longer behaving like a gas. Instead, it existed as a vast, flowing, fluid-like mass. In fact, Juno revealed that more than 90% of Jupiter is made up of fluid materials. This discovery marked a turning point in planetary science. Jupiter was no longer just a bloated ball of gas. Beneath its clouds lay a vast ocean of compressed liquid hydrogen, extending tens of thousands of kilometers deep under unimaginable pressure. This layer is so dense and dynamic that it acts like a gigantic electrical generator, producing Jupiter's powerful magnetic field. But this discovery raised an even deeper question. If Jupiter's interior is fluid, then what lies at the very bottom? What is this strange, fuzzy core that Juno detected? And why did it shock the scientific community? For decades, astronomy textbooks described Jupiter as having a solid core made of rock and iron, roughly the size of Earth. Scientists believed Jupiter first formed this dense core and then gathered gas around it. But in 2017, data from Juno shattered this idea. There was no solid marble-like core at Jupiter's center. Instead, there was a vast, mixed, and diffuse structure. Heavy elements like rock and metal don't form a clear core. They appear to be spread out and mixed with liquid hydrogen. This fuzzy core stretches across nearly half of Jupiter's radius. There's no clear boundary where the core ends and the outer layers begin. The leading theory suggests that about 4.5 billion years ago, Jupiter collided head-on with a massive planetary embryo, possibly 10 times the mass of Earth. This catastrophic impact would have shattered Jupiter's original solid core, scattering heavy elements throughout its interior. But here's where it becomes even more puzzling. According to computer simulations, those heavy elements should have gradually sunk back down and reformed a solid core over time. Yet in Jupiter, this has not happened. The core remains diffuse. This suggests that deep within Jupiter, there's still an unknown mechanism, preventing these elements from settling back into a solid structure. Jupiter is composed primarily of hydrogen and helium, much like the Sun. In terms of volume, it is comparable in size to the smallest red dwarf stars, yet it lacks the critical mass required to shine as one. For nuclear fusion to begin in its core, Jupiter would need roughly 75 to 80 times more mass than it currently has. Because of this deficiency, it remains not a source of nuclear energy, but a massive planet. To describe it simply as a gas giant would ignore the complexity of Jupiter's true nature. With its vast ocean of liquid metallic hydrogen, extending tens of thousands of kilometers deep, its enormous magnetic field and its boundary-less fuzzy core, Jupiter has fundamentally reshaped our understanding of how giant planets form. As our technology advances, our knowledge of the universe will continue to evolve. Until then, Jupiter will remain a magnificent world, silently rotating in the darkness of space, hiding its secrets beneath its storm-filled clouds. If you enjoyed this journey through Jupiter, make sure to subscribe and like the video for more documentaries about space, planets, and the mysteries hidden across the universe.